Alright, now let's proceed to the multi-stage countercurrent liquid extraction. So this is the ternary phase diagram. Okay, so we're going to relate now with what we have learned before based on the single stage and compare with the multiple stage. Okay, so in the single stage, you have your feed stream L0, your solvent V2, then you have your raffinate, which is L1, and you have your extract as V1. Okay, but in the multiple stages, you have L0, you have Vn plus 1, you have V1 and Ln. So the label must be according to the symbol of the stream that you have. And we have the x-axis represent the mass fraction or weight fraction of the solute, and then the y-axis represent the mass fraction or weight fraction of the solvent. Okay, and then I've informed you how to draw this particular line. So you need to have a straight line connect between the feed and the solvent, and then you should have raffinate connect with your extract. So the intersection point that you get between these particular two lines will give you the coordinates for M. M is very important here, okay, because you might need some information. Okay, you might have this particular line and only these particular coordinates. Okay, but if you know the coordinates for M, then you can just connect these 2 points and then extend the line, okay, until it's intercept to the y-axis. Okay, all right, so now let me explain. All right, so in the single stage, you don't have to calculate the number of stages, so that is very definite. Once you deal with the multiple stage, you need to know how many stages that you need to have in order to have the purity of your product that you would like to have. I have explained to you that we assume that our raffinate and our extract, okay, always at equilibrium, okay, and the composition are equilibrium composition, okay. So therefore, they must be labeled on the curve, okay, on the equilibrium curve, okay. So for the single stage, you just stop at this particular diagram. You cannot proceed some more because you don't need to find the number of stages because it is only one stage. But for multiple stages, look at here. Okay, so you have, this is called raffinate layer. Okay, so you might have a plate point here. Therefore, you have extract layer here. Okay, you're going to have extract layer. All right. So how to get the stages that you don't know between your first stage and the last stage? Okay. So this is how you're going to proceed. Okay. So this is the last stage information. And then the last stage information for the solvent is this one. Okay, all right. So this is the last stage, Ln and Vn plus 1. So these are the streams that you know the information for that particular first and last stream. So this is information at the last stream. Okay, and this is the information for the first stream or first stage that you have together with your V1. But what if V2 and V3? So you don't know your V2 and you don't know your V3, V4, V5 and so on until it reach Vn plus 1. Okay, same thing here. You just know L0, you don't know L1, L2, L3, but you know your Ln. Okay, so sometimes you don't have to have a complete coordinates to plot your Ln. Okay, because you know they are in equilibrium. Just to know your composition, or just to know your mass fraction of your raffinate for the solute, okay, the solute composition or the solute mass fraction for the raffinate, you just draw a vertical line until it's intercept the equilibrium curve. So that will be the point for Ln. Okay, so now, so once you have this particular Ln, L0, V1 and Vn plus 1, sometimes with the helps of your M coordinates to get the information based on the questions, right? So now your job is to draw two more important lines to get your operating points. Okay, so focus now. What you need to do is to connect L0 with V1. So draw a straight line from L0 to V1 and extend the line. Okay, next is to draw from Ln to Vn plus 1. Extend the line. Okay, so how to get the operating point? You need to draw extended line from L0 to V1 and extended line from Ln to Vn plus 1. So the intersection between these two lines that you have will give you a point, okay, maybe outside of the graph that you have. That is called the operating point or reference point. Okay, so you need this reference point. So once you know the reference point, now it's easy for you to know how to draw the tie line. So you have to connect between L1 to V1, L2 to V2 using dotted line. Okay, Ln, so definitely Ln to Vn plus 1. Okay, so by having this, okay, so this is stage number 1, stage number 2, and then you're going to have more stages, alright? So I'm going to explain how you relate this particular tie line so that you can get number of stages, okay? For this slide, I need you to understand how to draw and to get your operating point, okay, for multiple stage counter current LLE.